Okay, welcome everyone. This is solving quadratic equations by taking the square root. Um, the process of solving quadratic equations by taking the square root, we already talked about, right? When we have one variable, we're just gonna go ahead and solve it, but there's gonna be a little twist after we review the process, okay? So I see one variable, only the x squared, so I can go ahead and just solve it. I don't need any special technique, right? Like factoring or completing the square or using the quadratic formula. So that's 2x squared equals 16. And we divide it by 2, divide it by 2. So then x squared equals 8. And then I'm going to take the square root on both sides. So we have x equals, and since I took the square root, I need to add the plus or minus. Square root of 8. Square root of 8, we can break that down, go 4 times 2, and then the 4 can be broken down to 2 times 2, right? So then there's a pair of 2's right there. So that can come out of my square root. And what's left over is this 2 here, because that one doesn't have a partner to come out with. So that's my answer, right? Okay, we all remember that? We're going to review with 3 more problems and then jump into the new stuff today. So here I see one x variable, so I can just go ahead and just take the square root of it after I clean it up a little bit. So I am going to subtract 9. So that's negative 5x squared equals negative 9. Divide by negative 5, divide by negative 5. We divide by negative 5 to get the negative 5 onto the other side. So that is positive 9 over 5. And then once my square root, I have my x squared on one side. I can take the square root of both sides. And then we're going to have x equals plus or minus square root of 9 is 3 over square root of 5. But because I cannot have a square root in my denominator, I'm going to multiply it by square root of 5 over square root of 5. Remember, square root of 5 over square root of 5, what's in red is like multiplying it by 1. So we're not going to change the value. We're just going to make it look a little bit different, which is 3 square root of 5 over 5. And there is my solution there. Okay. I want to give you guys some time to do these two. Okay. So when we doing this, we're gonna again clean it up so I can get the x squared on one side. So I'm gonna subtract or add 24 to both sides, and then I have x squared equals 24. And then here I can square root on both sides. I cannot stress this enough. When we square root and we're solving for x, we need that plus or the minus. Okay, because it represents both numbers. Okay. 24, I can break that down into 6 times 4, 2 times 3, and then 4 is 2 and 2. It doesn't matter how you break it down. You're going to come out with the same answer anyhow. So x equals plus or minus. Here I see a pair of 2's. So 2 comes out. 2 doesn't have another 2. 3 doesn't have another 3. So they stay inside. And 2 times 3 is 6. So there is my answer for that first one. The next one here, I am going to subtract 13. Subtract 13. And then we have negative 4x squared equals negative 13. Divide by negative 4. Divide by negative 4. We have x squared equals positive 13 over 4, right? Then I can square root. Then I have x equals the square root of 13 over square root of 4 is 2. Oh, I forgot the plus or the minus. And there is my answer there. Okay? That's somewhat of a review, right? All right. So that was our review for 9.1, and here is the new stuff for 11.1. We're talking about imaginary numbers, okay? Imaginary numbers are numbers. Imaginary numbers are the square root of negative numbers. All right, the simplest square root value that we have is square root of 1, right? Which equals 1. So you can think about imaginary numbers being this variable I, okay? And that's just going to equal square root of negative 1. All right? So if I is the square root of negative 1, if I have the square root of negative 49, I can change up negative 49 to be negative 1 times 49, right? All under the square root. And now since the square root of negative 1 is I, this part here, this negative 1 here, changes the square root of negative 1 is I, and then whatever is left over, I just put it back. And then the square root of 49 equals 7. Okay? Notice that there's no plus or minus because I'm not solving. All right? So square root of negative 49 ultimately is going to equal square or 7i. All right? Let's try another one. If I have the square root of negative 108, okay? If I have the square root of negative 108, my first step is to get rid of that negative by making it into square root of negative 1 times 108. So it becomes I square root of 108. Right? Square root of negative 1 is I. So I just pulled it out. And I drew the I outside of my square root. Okay? And I know if I break down 108, I took the liberty of breaking it down. 108 is 12 times 9. 12 breaks out to be 4 times 3. 4 times 3 is, or 4 is 2 times 2. Right? And then a 9 becomes 3 times 3. Right? So I have all of these pairs. So I have a pair of 2s that come out right here. I have a pair of 3s that come out right here. And I still have this I that traveled. Okay. And then what's left over inside is this 3 here, which is still inside of my parentheses. Okay. So 2 times 3 is 6. That's how I got this 6. I square root of 3. That is your answer. All right. Let's try another one here. I want to make it up. Square root of negative, let's go 56. Okay. 56, I know that there's a negative. So you guys understand the process between the two previous examples? Yeah, since there's a negative, I'm just gonna take out the I square root of 56. We all understand that, right? Okay. So 56, I'm gonna break it out here, is what? 8 times 7? 8 and 7. 7 is a prime number. 8 can be broken down into 4 and 2, and then 2 and 2. So I have a pair of 2's that can come out, and that's it, right? And then what's left over inside is this 7 along with this 2. Correct? So 7 times 2 is 14. And then the I would travel along with me. So it's 2I squared root of 14. All right? That makes sense? Yeah. We have to break down the numbers if it's not prime. Okay. So since I equals square root of -1, there's gonna be a pattern that we're gonna do right now. I squared, you know what? I'm gonna erase this so we can do this together. Okay. I equals square root of -1. So if I take the square of square root of -1, essentially what happens is this squared comes out with this square root, and so it's going to equal -1. Yeah. So now I have I squared equals -1. I cubed, then I can rewrite I cubed as I squared times I. Correct? Yeah, I to the third power is the same thing as I squared times I. Okay, so if that's the case, I know I squared is -1, so that's -1 times I, which equals -I. I to the fourth, well, that is just I squared times I squared, right? I squared I know is -1 times -1, which equals +1. Yeah. I want to do one more. I to the fifth. I to the fifth is the same thing as I to the fourth times I, right? To the first. Remember we add the powers? Yeah. So 4 plus 1 is 5, so I can rewrite it like that. I to the fourth is 1 times I, which is just I. So do you notice that this is the same thing as my first step here? Yeah. So we're going to go through this 4-step process again. If I go I to the 6, I to the 7, I to the 8, it's going to go through this process. 4 steps, right? 4 different values. Okay? So that is the pattern. I equals square root of -1. I squared equals -1. I cubed equals -I to the fourth equals 1. I to the fifth is I to the sixth is -1. I to the seventh is -I. And then I to the eighth is 1. And it's going to go through this pattern again and again and again and again, right? So my question to you is, what is I to the 102 power? And I don't expect you to sit there. No one expects you to sit there and go through this process by hand. What do you think we should do? Hint, there's 4 different values for I, right? Exactly. Yeah, since there's 4 values, I'm gonna divide 102 by 4. Okay, that gives me 25, or let's just do this step by step. 4 goes into 10 2 times. 2 times 4 is 8. That's 22. That's 5. 5 times 4 is 20. 2, you have a remainder of 2. Yeah, that makes sense? We went back to second grade math, third grade math, primary school math, right? And now the key number to this answer, 25 remainder of 2, is actually the remainder. Because what the 25 tells me, the other number tells me, what this number tells me is it went through this process 1, 2, 3, 4, 5, 6, 7, 8, right? 25 times, right? Yeah. It went back and back and back and back like a wheel 25 times. And it stopped on the second one, the 26th time. That's the remainder of 2, right? So what value am I at? If I stopped with a remainder of 2. Am I at I? Am I at -1, negative I, or 1? I'm at -1. Okay. So this is actually equal to -1. That make sense? Yeah. So this would be a remainder of 0. If you have a remainder of 0, that means that it finished the pattern, right? This would have a remainder of 1. This would have a remainder of 2. This would have a remainder of 3. There is no remainder of 4 because you would finish out the pattern, right? Okay. All right. Now we are going to find the square of the imaginary number. So here, 5i squared, right? Getting the value of that would be 5 squared times I squared. 5 squared is 25 times I squared is -1. So this is -25. Getting the value of negative I square root of 2 squared. This would be -I squared times square root of 2 squared. This is -I squared times 2. I squared is -1 times 2. So that's -2. Okay. How about -2i? If I square -2i, that would be -2 squared times I squared. That would be 4 times -1, which is -4. This one's kind of funky. Square root of 3 over 3i. The square is distributed to each and every term. Okay, this squared goes to the numerator, goes to the denominator, and goes to what's being multiplied. All right. So square root of 3 squared is 3. 3 squared is 9. I squared, which is 1 over 3 times negative 1, which is negative 1/3. Okay? Make sure that the squared goes to each and every term. All right? Questions? No? Now we're going to go ahead and talk about solving with imaginary numbers. Okay, so we're going to just go ahead and solve them just like how we reviewed it in the beginning, where we subtract 12, and then we have x squared equals negative 12, and then square root. So we have x equals plus or minus square root of negative 12, right? It's negative, so I know there's an I coming out. And in the 12, I can break that down. Oops. I can break that down into 4 times 3, 2 times 2, so a 2 pops out. So x is going to equal plus or minus 2i. Square root of this 3 is left over, so there's a 3 inside. Okay. All we're doing is we're just square rooting negative numbers now. All right. Okay. So this next one, I'm going to subtract 11. So we have 4x squared equals negative 5. And then divide by 4. So we have x squared equals negative 5 over 4. Proceed by square rooting both sides. So that's x equals plus or minus square root of negative 5 is I square root of 5. Okay? Over square root of 4 is 2. Cool? Easy? All right. Try these two out. Let's go through this. So here on number 11, I am going to subtract 9. So we have 1 over 4 x squared equals negative 9. Divide or multiply by 4 to get x squared equals negative 36. Square root both sides. X is going to equal plus or minus. What is the square root of positive 36? 6, right? So I can just say, oh, this is just going to be 6i, right? Negative version is just 6i. Okay. number 12. We're going to subtract 3, subtract 3. And then we're left with negative 5x squared equals 7. Divide by negative 5, divide by negative 5. X squared is going to equal, if you're dividing by a negative number, that negative, class, get in the habit of putting it in my numerator. Okay? That's just good math practice. Square root on both sides. So we have x equals plus or minus I square root of 7 over square root of 5. Correct? Is that my answer? No. Right? We have to multiply this by square root of 5 over square root of 5 to rationalize my denominator, right, of 5. What's in my square root now? 7 times 5, which is 35. Yeah. You guys got it. All right. Cool. That is our lesson for today, class. Thank you so much.